Right, let's continue on with our bivariate data analysis. Today we're going to look at scattergraph. Pretty sure you've all done scattergraph in year 10. So we're talking about plotting graphs. How are we going to plot scattergraph? Alright, so by the end lesson, you should understand that a scattergraph is used to determine the association or correlation, those words you need to know, of two numerical data sets. Be able to identify, I missed the word identify, the explanatory and the response variable for the numerical data set. Be able to plot a scattergraph and draw a line of best fit by eye. So, line of best fit by eye is just estimation. We'll do a proper linear regression tomorrow. Be able to state the direction, form, and strength of the association. Understand the reliability of predictions using the scattergraph generated. All right. So, and you need to know how to construct a scattergraph. Oh, I've repeated myself. And comment. You must comment on the association between two numerical variables. All right. So this part is actually select and apply appropriate graphical or numerical techniques when we do a statistical investigation. So you have identified the problem, you have collected the data. So this part of it is analyzing the data. And then once you analyze, you have to be able to interpret and communicate. So things like the strength, the direction, and the form is actually interpreting and communicating after you analyze the data. All right? Now, what we are going to look at this time, we are going to use scatter plot because we are only looking at numerical data. All right? We are looking at both variables and numerical data. Scattergraph is also known as scatter plot, scattergram, or scatter diagram. It will give us an idea how the two variables are related. So in there are examples I have given you. Something like this something is going that way and something is decreasing. So don't know what the actual variable is, but you can see that you can sort of more or less fit a straight line. All right? This situation here is a study I've done many years ago, which is the average lawn size versus the average water use. And you can see that there's actually no relationship between the average lawn size and average water use. Basic reason is this was done before the water restriction, so there was no time limit and people can water that long as they like. So you can really see that there's no correlation or no association at all. All right, now we need to think about the variable. We've got two sets of data, bivariate data. And in this case, the variables are numerical. We've got variable 1 and variable 2. All right, yesterday we talked about explanatory and response variable. So let's revisit this again. Why did I say the high consumption of a particular foodstuff is explanatory variable? Why did I say death rates due to heart disease is response? So let's have a look at the definition. So the explanatory variable is a factor that can influence or explain the response. And it is known as the independent predictor. So I'm using this to explain the death rate, the consumption of particular type of food to explain the death rate. That is a response based on the explanation. All right? So the response variable is the dependent or the predicted variable, and you need to think about how you could reword it sometimes. So if I reword it in such a way that the death rates due to heart disease can be predicted by the higher consumption of a particular foodstuff, that you can see that that's a response, and that is the explanation. Why? Explain. All right, sometimes if you're not sure, ask yourself the question. Then you will see what is the explanatory variable and what is the response variable. All right? Now, the explanatory variable is the x-axis. Response variable is always the y-axis. So in the exam, sometimes they're given two axes already, and they have plotted the graph. they will ask you to identify. All right, that's sort of like the giveaway mark for you. That's all. So make sure that you know x-axis is independent, y-axis is dependent, or x-axis is explanatory, and y-axis is a response. These two words will be used quite a lot in the exam. All right, I'll move on. Now, so here I've plotted the graph. What I'm going to explain to you, what it means by strength, what it means by direction, and what it means by form. All right? Those are the things that you need to really know, because you may be asked questions like that. Now, notice that the points tend to form an oval shape from lower left to the upper right. Okay? This indicates that in general, countries with lower consumption of the food tend to have lower death rate due to heart disease. So you can see that it is the food consumption of that particular type of food, it's lower and the death rate is lower. And if you consume more, the death rate is higher. So there seems to be an association or correlation between the consumption of a particular food and the death rate. So there could be a relationship between this and that. All right? So can I use this to explain that? Maybe. We'll talk about it a little bit more. So the association and correlation, when we talk about that, when we interpret a scatter plot or scatter graph, you need to talk about the form, direction, and the strength. All right? Let's go through this bit by bit. Now, the form of scatter graph, it can be linear, non-linear, or totally no relationship at all. All right? You can see that the first graph, the one to the left, this is pretty linear. You can more or less fit a straight line in. I can put a ruler, and I can think of it as a straight line. Here, it's not possible to fit a straight line. Not here, not here, not here. There is a shape, sort of a parabola shape, but it's not a straight line. So the third one, there's absolutely no relationship at all, because it's scattered everywhere. You don't know how you could actually fit the data. There's no pattern at all. Look at the pattern. Linear, non-linear, and no relationship. Those are examples of the pattern. Linear pattern could be this way. It could be that way, negative slope, positive slope, negative slope. It could be horizontal, it could be vertical. All right? So we are generally talking about this or this when we're looking at most of the problems you're looking at. All right? Now, from there, there's a direction. There's positive correlation and negative correlation. All right? Next bit. So, if you've got a positive slope or positive gradient, there's positive correlation, because when the dependent variables go, the independent variables go higher, increases, the dependent variable increases as well. All right? So that's increasing. Whereas that is increasing, the independent variable is increasing, the dependent variable is decreasing. So you've got negative and positive direction. So you always look at it from the left to right, whether it's positive slope or negative slope. Quite important for you to know that. You'll be interpreting your y equals mx plus c again, the gradient. All right, strength. So you have to be able to discuss whether it is strong, moderate, or weak relationship. So strong is when you can see that if you fit a straight line in, the lines are actually pretty much close to that. The dots are pretty much close to the line. The data is scattered everywhere, but it's pretty much close to the line. All right? Here, the distance from the line a little bit further apart. And the weak relationship, here you can more or less fit a line in, but you can see that the distance, it's so far apart. All right? We will learn all this a little bit later because you need to learn what these are, the distance. All right? Look at this. This distance is very close, the vertical distance. The vertical distance. This one is all over the places. All right? You will learn, this is called the residue. We'll learn how to do the plot a little bit later. All right? So you can see why this is strong. There's no relationship at all. I mean, sometimes you can even interpret that as no relationship because it's really hard to find a relationship. That is definitely a strong, that's a definitely moderate. All right? At the moment, this period is all by eye. Tomorrow we'll be using a class mat and actually do it, work out the correlation coefficient. So the example here, A, do you think it's very strong? Yes. And in fact, for A, if you draw a line, and probably E as well, if you draw a line, you can see that the point actually goes through, the line actually goes through every single point. Those two are actually close to, it's a perfect relationship. The correlation coefficient will be 1. We'll talk about that tomorrow. That is like a perfect relationship. B is strong, very strong. C, I would say that there's no relationship. D, yeah, can possibly be very weak. F is debatable. All right? Now, so I've given you the names there, sort of the description there. Like A and E, perfect relationship. One is perfect positive, one is perfect negative. In real life, that only appears theoretically. Very seldom do you see that in experimental data. Strong negative, linear relationship. So when you are asked to describe whether it's strong or weak or moderate, describe the direction. All right, it's negative, not positive, and then describe the form, which is linear. All right, describe 3 things. Describe strong, positive, linear. All right, the form, the direction, and the track. That's important. This one is really, I would use no relationship. You can't be marked wrong if you say that there's no relationship. It's hard to tell if there's any relationship at all. All right? Now, line of best fit by eye. We could fit a linear model to the situation and use it to make prediction. So for example, using our line of best fit, we could suggest that a country with an intake of 45 kilograms per person per year of the particular food might have a heart disease death rate of 230 persons per year per 100,000 of population. So this, what I did is I do by eye. I just look approximately that line, the distance, they are averaged out to be about the same. So you cannot say that by eye if somebody fit that in. That is still correct. All right? By eye is very subjective. Your eye is different from my eye. So line of best fit by eye is very, very subjective. So you will get different sort of answer when you use that to predict. Now let's quickly talk about prediction. The reliability of prediction. The more data points we have on our scatter plot or scatter graph, the more confidence we have in any model we use. Now, the thing is the close fit of the point. So the closer the point lies to the straight line, which, well, like I said, the vertical distance, the more confident we can be in fitting a linear model to the data. If not, you would not know how to fit a model. All right? Now, here I have drawn a graph with a set of data and I fitted a straight line in. All right? And then somehow I try to predict it really way out there. All right? Look at the regions there. That, the region with all the data, if I use the regression line or the lines of best fit at this stage, within the known data set is called the interpolation. So if I want to find something here, I can use this bit, the line of best fit, y equals to mx plus c. You know the m, you know the gradient, you can estimate what that is. All right? Now, the next bit is sometimes people use the data, use the regression line outside the range. That's called extrapolation. You need to know these two words. When you're asked to explain and say whether the prediction is reliable or not, you got to say whether it's interpolated or extrapolated data. All right? That's very important. If you don't say that, it's hard, you'll be marked down for sure. So if I want to estimate when this is 20, if I use this line, the prediction is actually extrapolated, it's outside the data we've got. Whereas this, when it is 10, we know that it's within the data, within the range of known data, so it's called interpolation. Now let's talk about prediction. Reliability of prediction. Typical exam question, the interpolation versus extrapolation. Are we making a prediction for value that lies within the spread of our known values? If it is, it's known as interpolation. If you're making prediction for a value that's outside our spread of collected data, it's known as extrapolation. And it's less reliable. The word less reliable is important. All right? So, we often do tend to extrapolate beyond known data. For example, weather forecast is extrapolated a few days ahead. But the further ahead we attempt predict, the less reliable. So, like for example, Bureau of Meteorology will give you about 7-day forecast. They won't give you 14 days or 15 days because it's not reliable. All right, we'll talk about that extrapolation a little bit more and interpolation a little bit more later. All right. Now, you've got the data I've given it to you, which is ice cream sales versus temperature. The local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 12 days. So you got the noon temperature, which is this, and there's the ice cream sale. The owner of the shops wants to know if the ice cream sales is associated with the noon temperature. Construct a scatter plot of the data set, comment on the strength, form, and direction of the scatter plot, draw a line of best fit by eye. Now, the next bit, D, is talking about the prediction. The owner was told to expect 3 consecutive 30 degrees days. Determine the total sales for the 3 days and comment on the reliability of the prediction. All right, now plotting this, the first thing we need to know is what is the explanatory variable and what is the response variable. Which one is the explanatory variable? In this case? Temperature. And because the higher you will think that the higher the noon temperature, the higher the ice cream sale is. Correct? So therefore we know the noon temperature will be the x-axis and the response ice cream sale will be y-axis. All right, plotting it. You should be able to work out your scales properly. Now, generally in the exam, when you're asked to plot this, I would say that there are some missing data. That's all. And you're asked to plot 2 or 3 points. That's the trend that I've been observing. Rather than asking you to plot the whole set of data, generally what you need to do is just plot in a few points. And one of the comments from the examiners last year was a lot of students cannot plot the points. All right, that was one of the comments from the examiner last year. So make sure that you know how to plot the points. Generally, you'll be given the skills in terms of what you're expected to do. There are situations where I've seen questions that they didn't give you the explanatory or the response variable. You actually need to work it out yourself, although they give you the graph and the skills. If you haven't got a graph paper, come and get one for me. You've got a data in front of you.
What's with the form? What are the different forms?
Have you got graphs? You need ruler as well. And one of the advice that my old high school teacher gave to me is when plotting scatter graph, it's always good to have a transparent ruler. It's a lot easier to see how far the points are from the line. Plot a couple of points, then we'll go through. I'll show you my answer. Alright, once you've done that, done a few, this is actually the points I've plotted. Of course I cheated, I'm using Excel. I used Excel to do it. I did not do it by eye at all. Whereas the line of best fit I did. Alright. Now, looking at this, you can see that the data collected is within about 12 degrees to a maximum of 25 degrees. All right? You always read the question a little bit further ahead because you need to predict up to 30 degrees. So your x-axis should always be more than what you have. All right? Up to about 30 degrees. And always important, always label your axis. That's so important that label the axis. Now, from there, I describe it as a strong positive linear association. It is really strong because when I draw a line of best fit, right, I can more or less get all the points close to that line. The distance is not that far away from that line. And this is a linear relationship. You can fit a straight line in. Therefore, you can describe it as strong positive linear association. Strength, direction, and form. Now, when I drew the line, I actually use like I say, I cheated. I think, yeah, I did. I cheated. I used the Excel to plot it. So I label these 2 points that I use. Now it's important if you're asked to fit a straight line in, always label the 2 points you use. The examiner will always look at the 2 points you use to draw the straight line. Always label those 2 points. All right? That's so important. That's part of the exam techniques that you must have. Label the 2 points, draw it. Notice that I don't use the arrow at all, because it's not going on and on and on. It's not like y equals mx. I just use that. All right? Now, so when I can use that to estimate 30. So estimating it is about $760 or something like that. All right? Yep. So estimate ice cream sale for 1 day with noon temperature of 30 degrees is 760. And then the estimated sales for 3 days will be 3 times 760. Now, perhaps I shouldn't use the word accurate. Should say that the prediction may not be as reliable, all right, because it's extrapolated. So I would rather use the word reliable. I shouldn't, yeah. May not be reliable, not accurate, because the sale is extrapolated. So when you are asked to comment on whether the prediction is reliable or not, look at it. Just explain that whether it's reliable or not reliable. If it is reliable, it's interpolated. If it is not reliable, it's extrapolated. All right? So, what I've done today is gone through and talk to you about scattergraph, be able to plot it, and be able to do a line of best fit. All right? Important thing you should take from today is direction, form and strength, and the reliability. Stop now.